All right, y'all, so what I want to do with you in this video is show you how to use this website called Desmos to not only graph the data that we're going to get from experiments in this class, but also how to apply a line of best fit, or if it's not linear, a curve of best fit. So let's say that you're doing one of these experiments and you graph your data and you see it's going to have a trend that kind of looks like this. We know that is a positive relationship because the data goes up and not down as you read the graph from left to right. We're pretty sure it's a linear relationship because this looks like a straight line. We don't see it curving upwards. We don't see it flattening out like that. And so I'm going to assume that this probably takes the form of y equals mx plus b. We'll be able to put this into this website called Desmos, which is free and easy, and it's going to do a lot of the hard work for us. If I really wanted to know the equation for this the old-fashioned way, you could actually get out a ruler and draw a line of best fit and find 2 points and do rise over run, where the rise is y1 minus y2 and the x is, I think I said that backwards, x2 minus x1, and then slope is mx plus. Like, I don't want to do that though, and you don't want to do that. We want to use our technology. And so I'm going to go to a web browser of choice. If you just Google Desmos, it shows up like this. You're going to use the graphing calculator. Don't worry about the student or any other stuff, just graphing calculator. And you can come up here and put in a new table of data. And I've done this already with some sample data points. This kind of looks like the graph that I made. Notice that I can use the two-finger gesture to just zoom in and out, but also I can do it on the axes themselves to stretch or shrink this to make it kind of best fit my window. So what I want to do is have Desmos find the y equals mx plus b that best fits this data. I want to know the equation that relates whatever these two variables are. And I want you to notice here on the left-hand side up in this data table, they're calling the x and y values x1 and y1. This is our first table. Example number 2 is also going to be x1 and y1. We'll worry about that in a bit. X1 and y1 are important. So the deal is, we know that this is the equation of the line. What I want to know is what data fits our variables that we found. And so I'm going to be looking for an equation that fits y1 and x1 because that is the name that it's giving to our data right here. I mean, you can see it over here on the table. It's x1 and y1. But because these data points aren't perfect, you can see that there's not a straight line that hits all of them. And you humans are always going to be bad at measuring things. Don't take it personally. We're not going to say that it's equal. We're going to say, give me the line that best approximates all of that data. I want to know what line is the best fit that we can. You're going to make mistakes when you measure things. It's just that happens. You'll never be perfect. These data aren't on a perfectly straight line either. So I'm going to come over here and I'm going to say, give me a new expression. And I'm seriously just going to type in y1 is about, and you'll see that little tilde. All right. You really going to do this to me now, Desmos? Oh, there it is about right there. I don't have my keyboard plugged in right now. Is mx1, oh, see, it's already drawn a line on there, plus b. Maybe it's going to be a slightly better fit with or without a y-intercept. And a couple of things I want you to see on here. It'll give you the value for m, and it'll give you the value for b right here. These are the data that best fit. This is the line that best fits all those data points. You can tell we're off by a little bit. That guy is off by a little bit. That one's off. That one's off by quite a bit right there. But I want you to pay special attention to this number right here. If you take statistics in a few years with Mr. Cazzoli, he'll explain a little bit more about what's going on. In our class, when we're looking at how good our data is or how well your model fits the research that you've done, you're looking for what's called the R-squared value. And this is just a statistics thing. Okay, I didn't mean to highlight all that. It's a statistics number between 0 and 1 that tells you how good the line is at fitting what you're trying to do. This is an R-squared of 98.96. So we came back on this one, R-squared of 0.9896. What that means is that you are 98.9% right. This line is about, well, it's a solid A, 98.9. Now, these data all happen to fall on a pretty decent line, so it makes sense that works. All right. If our data points were off by a whole lot, if you had some really bad times collecting this, if you weren't very cautious, or if it was just like not really a linear thing, I mean, if you were trying to fit data that wasn't a straight line, what you'd see is a much worse number for your R squared. This data right here, that's not a linear trend. And so it's trying to fit this line, but sure enough, it's not a line. And so you're getting a 5% for R squared instead of a, what did I say before, 98%. Okay, but remember, that's for a line. The other equations that we're going to use, and it told you right there. The other ones that we're going to use for our quadratics is going to be y1 or whatever approximates a times x plus b squared plus c. And for our inverse ones, we'll have a over x1 plus b. And for the square roots, we're actually going to be able to just type in squirt for square root, a times square root of x plus b all plus c. So the other example I'm going to give to you here, I've already made some other data up. This is not a straight line, right? We can see that this data right here is still a positive trend because it's trending upwards, but it's not going in a linear trend. This is more of one of our root functions where it starts off kind of steep and then it starts to flatten out a little bit. So when I go to build this expression, if I say that this y, oh, come on, keyboard work, y1 is about mx1 plus b, you know, like that line is only about 90%. We really want to be higher, closer to 1. I mean, it's kind of a straight line, but you can see that that's curving, and it probably doesn't actually follow a linear trend. And so let's fix our equation right here. And let's say that it's actually going to be proportional to a, where's multiply, times, and you can just type in square root, and it'll know what that means. See, look at that, it already recognized x1 plus b. And I think I can just tap over to the side, and will it let me actually just do plus c. Okay. This data looks a lot better. This red line has an R squared value of about 0.98, which means this is 98% accurate. This is most likely going to be data that follows a square root positive trend. So what I want from all of you on your little lab write-ups today, the things that's going on the spreadsheet or on the Google Slides, is a screenshot of this. Let me get that out of the way. I want a screenshot of your data with the best fit line. I want to be able to see your R squared value on there for each of the 2 experiments. Right? And that's it. Hopefully this helped. Come see me if you have other questions.